Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're gonna talk about lens mount. So let's dive right into it. Well, first we have to understand why the heck a lens is so important. Well, first thing first, it's your core investment. You may think you may have bought a very expensive camera body. For example, Sony A7S Mark III. That's around 3 lakhs rupees. That's a lot of money. But you will quickly realize that over time, like maybe 1 year, 3 year or 4 year, you would have bought so many lenses, even small lenses, that price totaling up would be like, whoa, lenses are the more expensive part. And it has happened to me already, and I already have only two lenses, 70 to 300 and basically 24 to 70. So fundamentally your lenses will always be your core investment. Another aspect is lenses are very expensive. Many amateur people who are just jumping into it is like, let's this is my hobby, let's want to expand it. They have no context or awareness of it, how expensive lenses are. For example, there is this one lens that most people want to have, that is 70 to 200 f2.8, because this is one of the holy trinity lens, and not to mention it has very wide range, so to say. Like, what can you do with this? The answer is like almost everything. Like, it will not disappoint you. Basically, if you have this lens and you're saying I can't take a photograph unless you're talking about exactly ultra wide scenarios, this lens won't be your limitation. So many people want to buy that. But to give you an example of that, that's 2.3 lakhs in Sony, 2.1 lakhs in Canon, and 2 lakhs in Nikon. That's a lot of money. And the cheap edition, basically, where it's like, Tamron, like budget friendly option, that's around, hold your breath, 1 lakh. That's like, damn, that's very expensive. So fundamentally you have to understand, that is why people have to be very mindful about the camera, interchangeable lens camera they're buying, like, because it's a system. And from companies point of view, that is their main money making point. For example, let's say they send you one 5D Canon 5D Mark II. You bought it, you enjoyed it. Here's the deal. What's the first thing you're gonna do? You're gonna buy a lens. Then what's the second thing you're gonna do? You're gonna buy more lens. What's the third thing you're gonna do? You're gonna buy even more lens. You would be quite surprised how easily even common general people who's not going bonkers, they still end up with, like, 4 or 5 lenses easily. I have 2. So fundamentally that's the main bread winner for camera companies. That's why they want to keep it locked. They don't want to share, like, how the heck that's why the mounts of the camera mounts are not interchangeable. You can't use a Nikon lens on a Canon system, Canon lenses on that, because each company wants to make money out of you using selling you lenses. So fundamentally that's the whole point of companies. Basically, they don't make too much money out of selling you camera bodies, but they print money while they are selling you lenses. And this is what people refer to when they are talking you are locked into a system. For example, if I have a Canon system, I have 2 lenses, and if I go to let's say Canon full frame, one lens would be wasteful, but another aspect would be, at least I have that lens used, because one of my lenses is Canon APS-C lens. So that is a limitation, but at least I have some usability. But what happens if I jump from, let's say, Canon to Sony? Done, I'm stuck. Fundamentally I can't do anything about it, because those lenses, either I have to sell them in the second-hand market or just keep them as a backup. So that's why many times people are like, dude, we are stuck with it. So if you bought Nikon and you're like, I'm happy with Nikon, how they were performing, let's say, in 2010 and all that, you are happy with that, and over time you bought lenses, and now you're feeling like, hey, I don't think Nikon is doing good job, and you're like, okay, camera body, Sony A7S III for videos is not that expensive. But the moment you will look at the lens price, then you will realize the amount of money you will lose by keeping all those lenses as a paperweight. So fundamentally lens is your core investment. Everything else is chump change compared to it. Now, one thing you have to understand, I want to teach you the core specs of it, the core physics of it, so you can make decision on your own rather than asking whether this lens will work with that or not. So let's dive right into it. First thing first, projection area. Basically, how big of an image circle the lens is projecting onto a physical circle. You have to understand, lenses are circular things. They do not project rectangles. They project complete circles, and the circle must encompass the sensor. Otherwise you will not have basically, you're not gonna have a complete image. You will literally have black corners at the other end. Vignetting, extreme vignetting. So we'll start with the smallest, which is micro four third system, which is like around 17 millimeter by 13 millimeter. So very small system, and compared to full frame it's 2x smaller. So basically you can put 4 of them. And then you go to APS-C. I'm pretty sure most of you have experience with this, or maybe using this system as we're talking about. These are very popular, like from Canon 3000 series, Canon 3000 series, I'm saying. Yeah, there is one of that also, but Nikon 5100, Canon 800D, all those are APS-C. APS-C are like very most sold bodies, not lenses, bodies. That is around 23 mm by 15 mm, so sensor is a bit bigger. Then you come to the granddaddy, the full frame. Now why it's called full frame? It's simply because it's replicating 100% of the field of view of a negative camera, basically the film roll camera, that 35mm became standard, and it became standard for almost 100 years. So everything is standardized to that full frame 35mm. So when we say full frame, that simply means it's going back to the roots, it's exactly same size as your negative system. And back in the day, you could have literally bought, not even back in the day, like you can literally buy negative camera from Nikon and Canon and still use lenses that are made for DSLRs because they are intercompatible. So full frame, that is like 36mm by 24. That's huge. So at this point in time, this is the most upper limit of this, because there are, while technically there are lenses that are beyond this, medium format specifically, those are not mass production equipment. They are not like, you know, sold in hundreds and thousands and millions of them. Those are not mass production, those are specialty lenses. So we are talking about these three things that you have to understand. Now another aspect is everything is mechanical devices. These lenses are mechanical, they are not fixed, they physically move inside. So how the heck that is being accomplished? So there could be many technologies mixed into it. For example, Nikon was the world leader in terms of market share. Like it was like, dude, I am the king. So what happened? Basically Nikon at back in the day, you used to have negative cameras and they had like, you know, lenses had gears. That gears would be driven by the motor inside your camera. So camera had the motor to drive the lenses. Benefit, not so much, but I did from negative era, that was very practical, because back in the day, if you're talking about miniature motors, that was not a thing. So fundamentally back in that like 1960s and 1970s, that made sense. Nikon used that, and you can see its remnant in your modern Nikon cameras. You can literally take any Nikon DSLR and you will see a tiny lever. Like, why the heck there is a lever? Move it, you will find out it's moving the aperture. So fundamentally, it's what we call mechanical drive system. Now you go old, like very old system, 100% lenses were 100% mechanically driven. Right now, even Nikon is 50% mechanical, 50% is electronic. So basically autofocus algorithm, that's talking over the wire, but aperture control, that's directly talking through a physical lever. There is like a physical motor that's moving the damn thing, and that's why you don't find too many Nikon lens adapters, simply because while making a microprocessor that can talk from let's say one language of camera company to another language of a lens system, that's not that difficult. That's just a translation layer. But when you're talking about, okay, extract enough electricity, put that electricity in a capacitor, then drive a motor from that, is like, what? So fundamentally, that's why Nikon adapters are not that common. It is there, it's not like zero, it's just like good luck finding them. So that's the core reason, because it's a mixed mechanical system where it has electronic, which everybody likes, but it has mechanical, which is a remnant of old era. And that's why Nikon lost the market share, simply because Canon jumped into drive-by-wire very early on and they went all in. It's like, no, everything will be directly controlled electronically. So benefit of that is the lens motor is fine-tuned for that exact lenses. Aperture motor is fine-tuned for that system. So they were enjoying the market share. So drive-by-wire right now is the future. Every mirrorless is 100% drive-by-wire. Only mixed system that I can think about is basically Nikon DSLR lenses, simply because they have that aperture lever. So this is another limitation. That's why if you have Nikon system, you're like, dude, why the heck I'm not finding a lot of speed boosters, why I'm not finding a lot of basically adapter like that allows me to mount a Nikon full frame into a mirrorless system? Simply because of that aperture system. There are some manufacturers that have figured it out, but not that many. So drive-by-wire is another fundamental physical limitation. You cannot change it or bypass it. Then we come to two things that you will always hear: zoom lenses and prime lenses. Now commonly when we talk about zoom lenses, we think telephoto lenses. We are talking about like zooming, going closer to. That's not the true definition. True definition is basically you can change your field of view. So this will be basically, if I'm looking in this area, this will be what we call telephoto. If you stretch it like this will be wide. If you go like this will be ultra wide. So this is what we are talking about. When you're talking about zoom, it does not mean it has to be like, 100 to 700 or something like that. It could be literally from 18 to 35, still would be a zoom lens. If mm can change, that gets classified as zoom lenses. And prime lenses, that does not change. You can only change focus and aperture in a prime lens. So fundamentally, in earlier days, like as in like early 2000, everybody wanted prime lenses because the quality of prime lenses was much higher than zoom lenses. Zoom lenses had a lot of issues, like from chromatic aberration to vignetting to pin cushion distortion to barrel distortion. It had like hell lot of issue. But thankfully, advancement in optics design and a lot of computer modeling allowed us to make zoom lenses today that are like on par or almost sometimes beat old generation prime lenses. But prime lenses are still preferred because simply because they're simple. Another aspect, they are quite affordable affordable relatively speaking, and if you really get a high quality prime lenses, they will always beat out any zoom lenses out there. So but not, the gap is no longer like 70% versus 95%. The gap now is like 90% versus 98%. So gap has shrunk, but still there. So if you are a like paid photographer and you are like, I want the last quality, you will go with prime lens. That's why there are some weird prime lenses like 600 millimeter f2.8 prime lens. You're like, whoa. Yeah, its cost is very ludicrous because it's used in cricket photography a lot and football photography. So that's the core aspect. And three things you control. You control zoom. If you have a zoom lens, you control the focus, basically where it's exactly focusing, and then you control the aperture. Now these things can be electronically controlled, mechanically controlled, or flat out mix of both, because most lens have mix of both. So even though Canon lenses could have like electronic drive-by-wire system, when you move the actual ring, the ring is physically moving the lens element. That's the old design. The newer design, that ring literally sends the encoder data goes to your camera body moves the lens. Now benefit of that, really fast acquisition. Side effect, it's not very precise. So people who are used to manual focus, they hate this puppy. So it's like, and that's why in very early videos, if you see around 2005 and 2010, people were hating the system in Micro Four Third. It was like every lens was using drive-by-wire, and drive-by-wire was not implemented properly. So it was like, if you turn 45 degree, let's say the mechanical lens will move exact fixed amount. It's like 45 degree means, let's say focus shift from 2 meters to 8 meters. Let's say that's it, 2 to 8 meters. Here's the deal. In drive-by-wire system, if not implemented correctly, it was adding acceleration data. So if you moved it quickly, it will go from basically 2 meters to 20 meters. If you moved it slowly, it will come to around 2 to 7 meters. I'm like, what the hell? So that's why many times people do not like this lenses, specifically people who are dealing with video and they want to do follow focus. They hate this puppy. That they want a focus system where they can precisely control it. Drive-by-wire is not very good at it. Aperture control, it was a very big staple of negative cameras. Basically the cameras use film rolls. It was gone, done. It's a old era thing. And zoom, again, depending if you have zoom lens, you will have this. If you have prime lenses, you won't have this. However, if you buy a cinema lenses, all three will be accessible to you. None of them will have electric control, and in TV all three would be electrically controlled. So this is the core specs that we are talking about. So what is the problem here? Problem is, you can take a big projection area and cut out the useless part and project it on a smaller one. So you can literally take a full frame lens and be like, project onto APS-C. It's like, okay, got this, no problem. You can take an APS-C lens and say, project it to Micro Four Third. Awesome, got this, no problem. Here's the deal, you can't go backwards. Now physically in some scenarios like in Sony, Nikon and Canon, you can do the invert. So you can have a APS-C lens mounted, electrically compatible lens mounted on a full frame system. What will happen? Most cameras are smart enough that they will detect it, that you have mounted a wrong lens, and all they will do is crop digitally. So your sensor will go, let's say, from 36 megapixel to 24 megapixel, and you're gonna get a normal image. Like if you do not know about this, there are people who are using like APS-C lens or a full frame system and they don't even notice it, that they are getting less resolution simply because camera is doing the cropping in the background. But you have to understand that it only goes one way. So you can adapt basically only for smaller systems. So for example, let's say you want to adapt Canon lenses to Fuji system, you can do that. But can you do up let's say you like some Fuji lens and you're like, hey, I want to use that with my Canon. No, not happening. Only bigger can go smaller. So fundamentally, that's a fundamental limitation, cannot be changed, cannot be tampered with. Then we come to another aspect. You are talking about adapter, you are talking about physically mounting two things that are not meant together. It's like the mounting connection are not very electrical, so you need physical space. Now where is that space coming from? That space is coming from what we call flange distance. Now because of the DSLR technology that we used to have in Canon 5D and all that jazz, there is a mirror box. So that mirror box is gone, that's why we call it mirrorless. That gives old lenses, basically lenses that are made for DSLR, around a hell lot of space, around 2.5 centimeters of space. That's like, I can project that far, I can project till that far. But here's the deal, that means there is just giant gap. So somebody came out with it, like, let's make a mirrorless here, and this whole area that I'm like, let's say 2 centimeter area left for me, I can make adapters, because you still have to physically connect the damn thing. You cannot be just like, okay, I'm gonna attach it like this. Like, you're not taking star photo all the time. So you need a physical place for adapter. That can only happen if you have big flange distance. So if you think about mirrorless to mirrorless, So let's say for some reason you want to like, hey, E-mount lens, I'm happy with this E-mount lens, I want to use that E-mount which is full frame to is my Fuji basically, which is APS-C. So technically you should be able to do that, because full frame you can easily crop it down to APS-C. That's not an issue. But problem is, because the mirrorless lens does not have a flange distance, so you cannot take Sony mirrorless lens and plonk it on APS-C system. Fundamentally it will not work. So these are the two things. You can only go from bigger to smaller, and you can only do that if there is physical space, aka flange distance is there. Only then you can do this. And how do you know whether your lens has a flange distance? If it's a DSLR lens, it has to have a flange distance. So fundamentally, so you can mount DSLR lens into a mirrorless, not the other way around. So what does that mean? That simply means if you're buying a new system right now, you're like, okay, I'm jumping into this hobby, or I'm like becoming a photographer or something like that, going with mirrorless system allows you to access to two independent ecosystem. You will have complete mirrorless lens lineup that you can use, and you will have complete previous lenses of DSLR generation. You can still use it because there is a physical gap where you can put different adapters, and Canon made some amazing adapter. For example, one adapter was where you have variable ND built into the damn thing. So basically every lens you have, every full frame lens you are talking about, EF lens, will become compatible with basically ND filter. That's amazing for video work. That's like, damn, why the heck nobody else thought of that? Like, why the heck Nikon did not think of that? So fundamentally quite amazing things can be done. But so please be mindful, do not think like you can go from mirrorless to mirrorless simply because there is not enough place, physical place, to mount the damn thing. You cannot go from Sony to Fuji or Fuji to Sony. And Fuji to Sony would be another issue. Like, Fuji is designed for specifically APS-C only, so they cannot project to full frame. So these are the problem that you have to must understand. First, you can go down bigger, and then you have to figure about the space. Is there a physical space? How do you know about space? It's a DSLR lens. All DSLR lenses have flange distance. Now, what is the solution here? Well, solution is, if you are thinking about Sony E-mount system, you have to understand Sony came into the market around 9 years ago, and they were not making big strides because Sony had a previous system than that, Sony A-mount, which was not very successful. So Sony did something very interesting. They were like, okay, if you watch videos around 2012 and 13, you will notice a lot of people were joking like, even back then Sony was doing amazing body work. The body was like awesome, like, you know, advanced video features and all that jazz. Everybody was like, damn, this is awesome. But here's the deal, even back then people were like, dude, Sony lenses are not good. So the joke was, you'll buy Canon lenses in the future and gonna mount it with Sony system. It could be done because Canon was making DSLR lenses back then. So DSLR lenses can easily be mounted because of the flange distance, and it was full frame to full frame. It could be done. There are a lot of adapters right now you can buy. But to compensate for the lack of lenses, Sony did something amazing. They were like, okay, this is autofocus algorithm, take it and go. So Fuji, basically Sigma and Tamron both can now natively manufacture autofocusing lens for Sony system. Benefit, now the market is flooded with like basically native lenses you can just buy on Sony system. You do not have to be like, hey, I want this lens, is it available? No, you don't even have to think about adapters. E-mount, at this point in time, you have a lot of option, more than enough option. So they did that. However, be mindful that if you ever find it odd why the heck there is no image stabilization on lenses, simply because Sony did not open that part up. They are like, autofocus, go enjoy, but image stabilization, let that to be a first party system. So if you want lens image stabilization, be mindful of that. So Sony did that. So flat out in Sony you have a lot of lens selection. But what about Canon R mount? It's a new mount and it does not have 8-year experience, but you can easily mount EF, full frame EF. It can be easily mounted. Canon had already made adapters, and if you buy in sale or some big deals, you will find adapter to be in box itself, so you don't even have to purchase an extra thing. So, and Canon has largest basically lens selection. It's surprisingly easy to find adapters and all that jazz. Then we come to, okay, these are full frame to full frame. What if you want to go from full frame to medium format, basically medium format, I'm saying micro four thirds, like Blackmagic or Fuji. So at that point in time, you can utilize speed booster. Now here's the deal, there are options where you just have a simple adapter physically connecting those system, basically the lens to the sensor. You can do that, but problem is you are wasting technology. Basically the light you are saying, you are throwing it away. It's like, okay, just go it away, I am not gonna focus on you. But you can put a speed booster there which is gonna funnel that area, basically funnel that light into one concentrated area. Benefit of that is that crop factor will reduce. So crop factor will go from, let's say, 2x to, let's say, you can buy a speed booster that is like 0.71. So 0.71 would be reduced from your crop factor. You're gonna gain back that much light, so you're gonna get better aperture and better basically your telephoto effect will go down and your aperture will become much more brighter. So fundamentally you can do speed booster, and speed boosters are always available for Canon system, because again, drive by wire, Nikon one was not that good, that's why there are not that many options. And you can easily take EF full frame lenses to Fuji system, to Blackmagic Micro Four Third system, to any Micro Four Third fundamentally. So utilizing a speed booster, you can gain back some performance, so that's an option. Another aspect is, if you have any doubt, you can be damn sure Canon has a lens for it, and Canon lens has adapter for it, because it's fundamentally 45% of market share is Canon lenses. So mind-bogglingly amazing feat they have achieved. And be mindful, if you are doing critical work, if you are getting paid from it, I would urge you to stay away from adapters. Do not touch them, because even though electrically some companies figure it out how the heck to make communication between Sony lenses and Sony basically sensor system to a Canon lens system, it never works out reliably. Like, good enough here is like 90% of the time you're gonna be on focus. Again, that's fundamentally takes your amazing camera to like meh. So fundamentally, if you're relying on autofocus, do not touch these things. Most people who are talking about speed boosters and all that jazz, they are generally video shooter and they are using manual focus. So for those people, it is amazing. For those people, it's like, hey, I'm buying a cheap let's say Blackmagic camera and I'm enjoying the full frame lens performance. Not exactly 100% full frame, but you get the point. So these are the solution. In Sony, you fundamentally don't have to worry about, because Sony opened their mount system. Right now there are 3 companies, Sony, Sigma and Tamron, making lenses for it. So native lens selection is GG. And then you are Canon system, because Canon has a lot of EF systems. They have a lot of amazing adapters. Specifically, I really love that basically polarizer also you can buy for that. You can buy either ND variant or polarizer variant. That's also amazing, no issue there. And if you're like, hey, I want Fuji or Blackmagic or Micro Four Third systems, is like you can utilize speed boosters. So these are your options at this point in time. And if you're ever surprised why the heck Nikon is not that freaking aperture lever, that's a problem. So these are the solutions that you can employ in order to utilize your lenses, full frame lenses, on a smaller sensor. So this was my presentation on basically what logic goes behind into lens mount. Hopefully by this point in time, if you have paid attention, you could easily understand why the heck you can't mount Canon M mount to Canon R mount. And I'm hoping that if you liked it, learned from it, in that case you're gonna click the like button and share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me your disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.